IBHL test preparation. Good morning, Jed. How are you doing?
I'm good.
Jed, I'd like you to introduce yourself to my all the viewers. That'd be great.
So I'm Jad and I study in Frankfurt, Germany.
Great. So, Jed, today, what will you like to do?
Calculus.
Great. So, you're working for, you're preparing for IB test, right?
Yeah.
So, yes,
IBAAHL.
IBHL. Okay, great.
Yeah.
So, I have actually some questions for you. Let's go through those questions. I'll share with you a whiteboard and then we'll begin.
Right.
We'll discuss questions starting from limit. So, I have one great example for limit where I've seen students struggle to do the substitution. Question looks simple, but it is not that simple, right? So, the question here is you have to find limit when x approaches 1 for square root of x minus 1 over cube root of x minus 1, correct?
Yeah.
So in this problem, you notice that if I substitute 1, so I get 1 minus 1 over
So
minus
is
1.
one
So
minus one. Yeah.
it is an indeterminate,
Yep.
0 over 0. That means there is a common factor, and x minus 1, x equals to 1 is a common factor, right? That's why you get 0 in numerator and 0 in
Mm,
denominator. The best way
Yes.
to solve this question is substitution. So tell me, from the knowledge of substitution you have, what kind of substitution will you do here?
Hmm. Uh,
So,
or maybe try the cube root of x
okay. So basically, either you do square root of x as y
or
or cube root
or
of
cube
x
root of
as
x.
y.
Yeah.
You cannot write the other in whole numbers, right? You get 2 over
Yeah,
3
that's
or something like this, right?
yeah.
So the trick here is that let me share with you the trick. See, when you look at square root of x, it is basically x to the power of half, right?
Yeah.
And when you do cube root of x, it is basically x to the power of 1 by 3.
Yeah.
Now, working with half and 1 by 3 gives you an idea that common denominator 1 by 6 can work beautifully with both of
Oh,
them.
that's true. Yeah.
So let's substitute u as x to the power of 1 by 6. You understand?
Okay, yeah.
So that is a substitution which you have to do, and that is why this question, which looks simple, but it's very difficult, especially in
Yeah.
a test when you just get
Just
this
if
question. Yeah, this may not strike. So that's the
yeah.
whole idea, right? So as soon as you do, u equals to x to the power of 1 over 6.
Yeah,
Now,
it's easy.
now if I do the square of this, I get 1 over 3, right?
Yeah.
So u square will be equal to x to the power of 1 over 3. And sorry, I wanted to write u square.
Yeah.
U square is this, and u cube is x to the power of half, correct?
Yep.
Now also you notice when x approaches, I should write x first. When x approaches 1, u also approaches 1, correct?
Yes.
Sixth root is 1 for 1. And therefore, we can rewrite our limit as u approaches 1. And instead of uh, this, will square root is actually u cube. So u cube minus 1 over u square minus 1. Makes sense?
Yes.
Now it's very simple. You know that it can be factored in the form x u minus 1 times u square plus u into 1 plus 1 square, right? And denominator is u minus 1 times u plus 1, correct? And
Yes.
these cancel. And now you can substitute 1 and you get the limit of this function. Let me substitute 1, right? So, so the limit is equal to 1 square plus 1 plus 1 over 1 plus 1, which is 3 by 2. Do you see? So for this
Yes.
limit question, the substitution, which is of great importance, is u equals to x to the power of 1 over x. Makes sense, right? So
Yeah.
take common denominator and then do the substitution. Correct. So on the other computer, I've loaded your questions because on this computer, it's becoming difficult for me to
Mm,
upload the files.
No problem.
Yeah. So next question we'll take from the other computer, where we're looking to derivatives when logarithms are used, right? So here's a very beautiful question. Let me just share that with you. Okay. So the question here is y to the power of x is equal to x to the power of y, right? And dy dx is equal to ln A minus C over ln B minus D. So you have to find dy dx from this particular equation in this particular form. And then the question is, you need to find the value of A times B times C times D. What do you get? That is the question. Okay.
Yeah.
Now, how will you do this question, right? So it is like y to the power of x equals to x to the power of y. We need to find dy dx, right?
Yeah.
So here also we have a very beautiful technique to do it, which I'm going to discuss, and that is going to help you to answer such questions in a shorter period of time, right? So we need to figure out this derivative, right? So for such cases, we can take log on both the sides. Log converts exponents into product form, right? And makes things very, very simple. So if I take ln on both sides, see what happens, right? So I'm taking ln of this and ln of this, right?
Yeah.
So as soon as I take ln on both sides, I can rewrite this expression as x times ln y, right? Equals to y times ln x. Makes sense, right?
Yes.
Now we have x times ln y and y times ln. And derivative of ln x or ln y is 1 over x or 1 over y dy dx, correct?
Yeah.
So we can apply the product rule on both the sides, correct? So if I apply the product rule now, so differentiate with respect to x, right? On both the sides. So product rule, derivative of x is 1, so we get ln y, right? Plus x times derivative of ln y, which is 1 over y dy dx. On the right hand side, derivative of y will be dy dx, ln x plus y times derivative of ln x, which is 1 over x. You see that?
Yes.
And now we can bring dy dx terms together. So if I write dy dx on the left hand side, let's say, I get what? X over y, and this one minus ln x. And here we get y over x minus ln y. Correct? So
Yeah.
I brought dy dx terms and then took dy dx common. Correct?
Yes. Yes.
We need to find dy dx. So dy dx will be equal to uh, y over x minus ln y over x over y minus ln x. Correct? Well, in the question, we had to write it in ln first, right? So I'll rearrange it, taking minus both sides as common. I can rewrite this, right? So I get what? I get ln y minus y over x over ln x minus x over y, correct?
Yeah.
So now we have our A, B, C, Ds, right? So A is y, B is y over x, C is x, and D is this, right? So we can now multiply those terms, right? Which is y times y over times x over y, correct? So you see one of them gets cancelled and we get xy as our answer. Do you see that question?
Yeah.
So getting back to this problem, we were given that you need to find a derivative, which is of the form ln A minus C over ln B minus D. It gives you a hint that use logarithmic derivatives, right?
Yeah.
And therefore, you should take ln on both the sides. And once you do that, then take derivatives with respect to x, apply the product rule, and then take dy dx common and do as we did, right? To get the answer And that gets you to the second question. Is this process clear to you?
Yes.
Hmm? So logarithmic derivatives are they make things very simple. Since they're derivatives, very simple, right? 1 over x kind of a thing. Okay, great. Uh, so once you've taken note of this, we can take up some optimization questions, okay?
Okay.
Just
All right.
great. Now, in optimization, I'll take a general question which will help you answer questions very fast. Normally, you are given this question that let's take a box, let's take a square tin, right? Let's say we have a square tin. And from each side, we have to cut the squares, right, of equal side. Now, these are very popular questions. So from each side, let's say we cut a square of x units, length and width, right?
Yeah.
Correct. Now I'm taking it a very general question. So means let the length be a units, right? It could be anything. So once you have a solution with general parameters, if you get this question, you have a answer immediately in your mind. That's the huge advantage. Correct?
Yes.
Right. So now the idea is to cut squares from each corner, and then when you bend it can hold some liquid, and we want to maximize the volume of the liquid. Correct. So what you've done so many times is that when you cut from x units from both the sides, the length left here will be a minus 2x, correct?
Yes.
And similarly, a minus 2x is the width. Well, in case of a rectangle, they will give you a and b, and you can do the same thing, right? So the volume is equal to x, which is the height, times a minus 2x, which is the length, and then a minus 2x, which is the width. So that's what volume is, which you can always write as x times a minus 2x whole square. Correct.
Yeah.
You also notice here what could be a, right? A could be, what could be x? X could be 0, right?
Yeah.
It could be maximum half of a, right? Correct?
Yes.
Half of a. Because the same half and half will give you the full length. You
Yeah.
cannot go
It's
beyond
kind
that, right? So let's
yeah.
say greater than equal to. So why I have done greater than equal to? Well, many times we say, well, we have to cut, we should have some dimension on the top, but let's say it's a very fine cut, approaching 0. That's the whole concept.
All right.
So approaching half a will
Yeah.
give me the higher limit, right? Now, when these are the values, we can always see that the volume for A will be what? As soon as I mean 0, sorry. This looks like A, so just let me write better. 0, right? So volume when X is 0 will be 0, right?
Yes.
Even when we put half A here, right, it will be also 0, right? So
Yeah.
volume is, you can see, is 0 for both the limits, right? So when we have defined the restriction of the variable, in that case, we know now any value which you get in between will be maximum, correct? So we don't really have to find the second derivative and then show that, well, the second derivative is positive or negative, and therefore it could be maximum minimum, right? Or nor do we have to do the interval test to prove that this is the maximum value indeed, right?
Yeah.
Volume, of course, will be a positive number, and any positive number is greater than 0, correct? So the
Yes.
critical number here gives us actually the maximum value, but you have to show this, right? It's kind of important, right? Great. So let's find the derivative of this particular function, which is right here, right?
Yeah.
I mean, let me use different. Okay. So the derivative of this function is apply the product derivative of x is 1. So we get a minus 2x whole square plus a x times derivative of a minus 2x whole square means times 2 times a minus 2x times derivative of inside function, which is minus 2. Clear? So that should
Yeah.
be equal to 0 to find the critical number, right? Now, to simplify this, the best way is, you can always expand, simplify, do everything. But keeping factors is, again, a very important step. So you should have factors, right? So we have a minus 2x as a common factor, you can see, right? Here and here, right?
Yeah.
Once you take that, we are left with a minus 2x from the first term. And from the next term, we have minus 2 times 2, 4, minus 4x, correct?
Yeah.
So we could write this as a minus 2x times a minus 2 minus 4 minus 6x. So that is the derivative of this function. We are equating it to 0 just to find the critical number. Now there are two possibilities. So we have a minus 2x equals to 0 or a minus 6x equals to 0. So that gives me 2x equals to a or x equals to a by 2, correct?
Yeah.
And this gives me 6x equals to a or x equals to a by 6. Now this is already a boundary condition, right? So, but, right? So if you want to check, we have already checked for that boundary condition, right? This is the boundary condition. So strictly speaking, the critical number here is a by 6, right?
What do you mean by boundary condition?
I mean, it was, strictly speaking, it is to be slightly less than half a, right?
From yeah, yeah. So then it's okay.
Yeah, we already checked the value. The volume of water or liquid will be 0 for this value, right?
Yeah.
Now, so that clearly shows that volume is going to be maximum for x equals to a by 6, 1/6 of the length of the square. Do you see that important formula right there?
Yeah.
And we can find the volume here. How much will that be, right? So the height, let me write the formula first and then we'll plug in this. You'll plug in this, right?
Yeah.
X was what? X into a minus 2x whole square, right?
Yeah.
Because it's a square length and width the same. Now we'll plug in a by 6 in it. We get a by 6 times a minus 2 times a by 6, right? Whole square.
Yeah.
So which is a by 6 times a minus, this is 1/3, right?
Yeah.
So that gives you a by 6 times 3 minus 1, 2, 2a by 3 whole square, right? Which I can write a by 6. 2a means 4a square, correct? And 3 square is 9. Clear?
Yes.
You can simplify and write down the expression dividing by 2. We get 2 and 3. 3 times 9 is 27. We get 2a cube over 3 times 9, 27. Whatever unit we have, right? A unit cube.
Yeah.
You see that? So what we have shown here is that if you are working with a square and cutting the corners of x unit from each side, in that case, the maximum volume of an open top cube, rectangular prism, open top, will
Yeah.
be 2a cube over 27 when x is 1/6 of a. You see that?
Yes.
Extremely important relation for us. Because if this kind of a question comes, then even before starting the solution, you know the answer. You get the whole idea.
Yeah.
So that's the beauty of this particular question. So take a note of this, and then we'll take another type of question. Now, these questions are very popular. Sometimes they take a rectangle, square, something like this. So it is kind of similar approach. So you can remember that 1/6 of the length should be cut to get the maximum volume of the liquid.
Yep.
Oh, great. Now, so this is kind of a geometry when we look into optimization questions. Now I'll look into another type of a question, which is, let's say, Anil and Jed. Let's say, uh, so I am north of you. I'm in Canada. You are in Germany. So let's see. But let's say, okay, let's make this axis here. So let us say, so here's a very important test question for you, which will work out now. So let's say that Anil is north of Jad. So Anil is here. So whenever we take two persons, we put one person on the origin, right?
Yeah.
So we say Anil is north of, let's say 20 kilometers, right? So let's say this is 20 kilometers north of Chad. Great. And let's say we are practicing for some marathon or some competition, right? And so one day what happens is that at 6 a.m. in the morning, Anil jogs towards south and Jad jogs towards east. Okay. So that is the scenario we work like this. And let's say this they do it for, let's say, 3 hours. 3 hours practice. Correct. Now, in this particular case, when they are jogging for 3 hours, so let us say that the speed of Anil is 6 kilometers per hour. So let's say Anil is jogging at 6 kilometers per hour, and Jad is doing at 8 kilometers per hour. Now the question is, when will they be closest? So closest will be the distance between them. So at any instance of time, this is,
Yeah.
we say, as separation between them, right? So
Yes.
that is the distance which we are looking into, and that should be the minimum. When will it be minimum? This is what we need to figure out. Okay.
Okay.
We're saying this is north and that is east for us. So how will you do this question? Let's say 8 kilometers per hour. So in time t, Jet will go 8 into t distance away, right?
Yeah.
Anil will cover 6t
60.
distance, correct?
Yeah.
So how much will this be? This will be 20 minus 60, correct?
Yeah.
Correct. Because 20 was earlier, 60 has been covered. And therefore, the separation S, you can say, will be 20 minus 60 whole square plus 8t whole square. Correct?
Yes.
So that is going to be the separation.
Yep.
Now, to minimize this particular separation, and here also, we have a time frame t. T could be from 0 to, we are saying 3 hours, correct? So once we find a critical number, we will check the separation using this particular formula. What is the separation at t equals to 0? What is the separation at t equals to 3, right? And what is the separation at our critical number? Is that clear?
Yeah.
Now let's find the critical number by finding the derivative. So ds dt will be equal to, so this you can think like to the power of half, so it'll be half of this to the power of minus, right? So think like this is half, and then all this to the power of minus half, so it'll come in the denominator. And in the numerator, we'll have to write the derivative of the inside function, right? So derivative of the first function is 2 times 20 minus 60 times the derivative of inside function, which is minus 6. Plus, here it will be 2 times 8t times 8. Okay.
All
Now,
right.
to find the critical number, we equate it to 0, right?
Yeah.
We equate this to 0. Well, we could simplify also. We can cancel these 2's. Correct?
Yes.
So we have minus 6 times all this. Let's open this up. So basically the numerator should be 0, right? So I could write minus 6 times 20 minus 60 plus 8 times 8, 60/40. We get this equation, right?
Yeah.
So we can open the bracket, and so 6 times 20, 6 times 120 minus 30/60 plus 60/40 equals to 100.
Yeah.
That is 100t equals to 120 is taken on this side. Is that clear?
Yeah.
So we can now divide by 100.
Yeah.
1 point. So after 1.2 hours, their separation will be minimum. But to prove
Yeah.
that this is so, what we can do is we can find the value of separation now, right? So separation was how much? Square root of, so vertical 20 minus
So
60 whole square
60.
plus, I'm just writing the formula first,
Yeah.
80 whole square. Now we'll do it for all the
Substitute.
numbers. S0, plug in 0 first, right?
Yeah.
So 0 will give me 20 square, right? Which is 400. And then square root will be 20 itself, correct?
Yeah.
I can write down 420. Is that clear? Plus
Yes.
20 square root. Okay, that was easy. Now we have a critical number, 1.2. So use calculator, tell me what value do you get when you plug in 1.2 here.
Yeah.
So when you do it, you get square root of 256, which is 16, right? It is much lower than 20, right?
Yeah. Yeah.
Now the other limit is 3 because they ran for 3 hours, right? So if I put 3 here, then I get square root of 20 minus 6 times 3, right? Which is 18 whole square, plus 8 times 3 whole square. Do this. So 20 minus 18 whole square is just 4, right?
Yeah.
Plus
And then 8 times 3, which is
24 square, right?
squared.
Yeah, plus, yeah, so 580 square.
Oh, yeah.
So the separation you can see is minimum at 1.2, right?
Yes.
So what will be the time? So they start at 6 a.m. and in hours it is 1.2 hours. So zero point 0.2 means into 60, right?
Yeah.
And therefore the time will be 7 hours
7,
and
12.
12 minutes.
Yep.
That much AM, right? You see that?
Yes.
So that is how you're going to solve this particular question based on optimization, where speed and distance and time is involved. Correct.
Yeah.
So we took up
It,
two different types of questions. I hope you find them useful, right?
yes.
So we'll end the today's class at this point and then continue from here next time.
Okay.
Okay. So
Perfect.
I'd like you to summarize the learnings today. So what did you learn today?
So we did a question with we started off with limits.
Yeah.
We did a simple question, but there's a small trick to it that like you need to take notice, especially in a test it's hard,
Yes.
where you find a common multiple between the two
Correct.
x's. So then we did a question with natural logs. Then we went into optimization. We did one with a square,
Yeah.
and we found the volume, the minimum volume of after cutting the square up by um, x by x.
Yeah.
Um, so that got us when x would be x by a by 6,
A by
which
6. Correct.
a by 6, which got us 2a cubed on 27.
Correct.
And then lastly we did also optimization, but it was a bit different,
Mhm.
which which was more of like a minimum
There's a
distance and
separation between the two
separation between the
runners,
two.
right?
Yeah.
So that's great. So, Jed, that's nice. We'll continue from here. More calculus tomorrow. Perfect.
All right.
Thank you. Bye.
Thank you.
Have a great day. Join Anil Kumar classes and learn more. Thank you.